In this video, I will talk about degrees of freedom. Degrees of freedom are the number of independent parameters or coordinates required to completely describe the position and orientation of a system in a space. And our system is molecules. For a molecule with an atom, total degrees of freedom is 3n. 3 represents the translational, rotational, and vibrational motion. The degrees of freedom of vibrational modes for a linear molecule is 3n minus 5, and for a nonlinear molecule it is 3n minus 6. Basically, each atom has 3 degrees of freedom. Why is vibrational degrees of freedom different for linear and nonlinear molecules? As I mentioned, linear molecules has 3n minus 5 vibrational modes. 3n is for the translational, rotational, and vibrational modes. And minus 5, one of the source of the minus 5 is the translational modes. So a molecule can move as a whole in the three-dimensional space, x, y, and z. This accounts 3 degrees of freedom. And molecule has also rotational modes. Molecule can rotate its center of mass, but linear molecules can rotate on intermolecular axes, which doesn't change the molecule's orientation or position in space. Therefore, linear molecules have 2 rotational degrees of freedom. So as you see, we have minus 2 rotational and minus 3 translational modes for the linear molecules. And you may not understand what is the intermolecular axis. So for instance, we have a CO molecule. CO has a triple bond with the oxygen, and if you rotate the molecule, for instance here, which is the, for instance, x coordinate, the orientation of the atoms will change. If you move the molecule or rotate it from the z-axis, it will also change the orientation of the atoms. However, if you rotate the molecule in y-axis, orientation and position of the atoms will never change. Therefore, we have 2 rotational degrees of freedom for the linear molecules. Why is degrees of freedom important? Every molecule has total of 3n degrees of freedom. As we mentioned, 3 of them translational, 2 or 3 of them rotational. It depends on the linear and non-linear molecules. The remaining degrees of freedom must be used for the internal motions of the atoms, which is vibrations. Calculating the total degrees of freedom and subtracting the translational and rotational ones gives us the exact number of ways a molecule can vibrate. I can make an example to explain the concept, and the example can be a water molecule. As you know, water has a band structure. We have oxygen in the center. We have 2 hydrogen atoms attached to oxygen atom. So total degrees of freedom for this molecule is 3n. And n here is 3 atoms. Therefore, we should write 3 for n. And at the end, we have 9 total degrees of freedom. We have 3 translational degrees of freedom, and we have 3 rotational degrees of freedom. If you want to find the vibration degrees of freedom, we have to subtract these two trees, which will be 9 minus 6 and 3, so that we have 3 vibrational degrees of freedom for the water molecule. You may ask, how can we find the Raman and infrared active modes? And this will be next video for this series. So I will not talk about the infrared and Raman active modes here. It is the subject of group theory, and I will explain it one of my next video.